what are these? Today we'll discuss the introduction to combinational circuit. So basically in the digital there are two types are there, combinational circuits and sequential circuits. So combinational circuits and sequential circuits. So that means if you see like so that means a digital electronic. So you have that combinational and sequential. So combinational circuits and sequential circuits. So combinational circuits are nothing but output is depends only on the present input. Output depends only on the present input. Present input. And next output depends on the present input, and sequential circuit is nothing but output depends on the present input as well as past outputs. Okay, output depends on present input as well as past outputs. Past outputs. Okay, so so if you see this is a combination circuit. So you have set of inputs. Let us take K inputs. These are the inputs. You are getting the outputs. Okay. So this is a combinational circuit. So if there any change in the input, there is change in the output. Okay. That is a like a combinational circuit. And sequential circuit is nothing but this is a so it's a combinational circuit, and there will be a feedback. So these are the inputs. These are the inputs, and here these inputs will be feedback, and you have a some memory
Sir,
element.
are you sharing the screen, sir?
One second, one second. Sorry. Now, now it's visible. Now it's visible. Just to give response.
No, no, sir.
Not visible.
No, sir. Ah, okay, sir. Now it's good.
Yeah. So basically, we are discussing about the difference between the combinational and sequential. So combinational circuit, the output depends only on the present input. Okay, so you can say that output is a function of only present input, and here output depends on the present input as well as the past output. So you can say that output is a function of present input as well as the past outputs. The output depends on the present input as well as past outputs. Okay, and if you consider like combinational circuit, no feedback is there. There is no feedback in the combination circuit, and no memory is there. No memory is there. Okay, and in the sequential circuit, you have the feedback. You have the feedback, and memory is present. Memory is present. Okay. So example for combinational circuit. So we are going to discuss so many combinational circuits like half adder, full adder, and half subtractor, full subtractor, and mux, demux, and encoders, encoders, and decoders, okay, and code converters, comparators. All these are nothing but combinational circuits. And sequential circuits are nothing but we are studying about latches and flip-flops and counters, shift registers, shift registers, and flip-flops, shift registers and FSM, finite state machine. Okay. So in the finite state machine, with the help of finite state machine, there are two types are there, Mealy machine and Moore machine. We are going to design sequence detector, and uh, serial adder, serial adder. Okay. This finite state machine is very much important when you are going to the project, either DV training. When you do the project related to like I2C, SPI or UART, so there you are using FSM only, finite state machine. Okay, it is having the finite number of states. So that there we'll discuss, and I will tell you all this when we discuss the combinational circuit and sequence circuit. Is it fine? Do you understood? Shall I move forward? I am waiting for your response.
Yes.
Okay, sir. For
Shall I move forward? Any doubts or queries? Hello?
No, sir, no doubt.
Okay, okay, sure, thank you. So, you need to design the combinational circuit. How to design the combinational circuit? Okay, designing of combinational circuit. Okay, designing of combinational circuit. Suppose this is my combinational circuit, which is having inputs, inputs, and which is having the outputs, set of outputs. Okay, inputs and outputs. This is my combinational circuit. Step one. So there are some steps are there. Step one. Uh, determine the determine and define the total number of inputs and total number of outputs of the circuit. Okay. Determine, determine, and define the total number of inputs and outputs. Okay. So that means of the circuit. First, you need to find out how many number of inputs are there, how many number of outputs are there. So, any problem is given. So, you need to identify the number of inputs and number of outputs. Okay. And step two, you need to make the truth table. You need to make the truth table. Need to make the truth table that defines the relationship between input and output. That defines the relationship between input and output. Okay, and step 3 step 3, determine the Boolean equation using K-map. Determine the Boolean equation Boolean equation using K-map. Okay, and next step 4 uh, so based on the Boolean equation we can form the circuit. Based on the Boolean equation we can form the circuit. So these are the steps you need to uh, follow when you are designing the combinational circuit. First, you need to identify the total number of inputs and outputs. Okay, and you should make a truth table based on the relationship between input and output, and determine the Boolean equation using K-map. And based on the Boolean equation, we can form the circuit. Okay, so these steps are fine. Is it fine? Or any doubts or queries? Shall I move forward?
Fine, sir.
Waiting for your response.
Fine, sir. Move forward.
Okay, yeah. So first problem we'll see. Okay, uh, you need to like designing of combinational circuit, designing of combinational circuit. First problem, the minimal function that can detect. So you need to design the minimal function that can detect, that can detect uh, divisible by divisible by 2 divisible by 2 with 8421 BCD, 8421 BCD. So let us take the BCD inputs are D8, D4, D2 and D1. Okay, D8, D4, D2, D1 is given by okay dash. So we need to find out the minimal function that can detect divisible by 2 divisible by 2. Okay, so here first, what is the first step? You need to find out the number of inputs and number of outputs. So how many number of inputs are there? So this is a BCD code. Total 4 inputs are there. And how many number of outputs are there? Only one output is there. Why? Okay. So that is the first step. And depending on the relationship between input and output, you need to draw the truth table. Okay. So here you need to draw the truth table. Here I am drawing the truth table. Let us take the inputs are D8, D4, D2 and D1. Okay, and next output is Y. Okay, so this is the BCD. So BCD means the range of the BCD is from 0 to 9 only. No, range of the BCD is binary coded decimal. The range of the BCD is from 0 to 9 only. Okay, so 0, 0, 1 and 0, 0, 1, 0, 0, 0, 1, 1 and 0, 1, 0, 0, 0, 1, 0, 1 and 0, 1, 1, 0 and 0, 1, 1, 1, 7 and 1, 0, 0, 0 and 1, 0, 0, 1. Okay, this is 9 from okay 0 to 9. Okay, this is 0 to 9 and from 1010. Okay, from 10 to 15. Okay, let us take 15. 1111. Okay, these are don't cares only. These are nothing but don't cares only. Okay, from 10 to 15 we'll consider 10 to 15. Okay, we'll consider the outputs are don't care only. Why? Because BCDs are defined from 0 to 9 only. Okay, now based on the problem, just see the problem, minimal function that can detect divisible by 2. So is 0 divisible by 2? You are getting remainder 0, no? Output is 1. Is 1 is divisible by 2? No, it will not divisible by 2. The output is 0. Okay. If the number is divisible by 2, you need to make it output as 1. Okay. And 2 is divisible by 2. And 3 is not divisible by 2. And 4 is divisible by 2. And 5 is not divisible by 2. 6 is divisible by 2. 7 is not divisible by 2. 8 is divisible by 2. And 9 is not divisible by 2. Okay. So by seeing this truth table, what are the min terms you need to draw? You need to write summation of m of 1 to 0 to 4 8 4 6 6 and 8. Okay. So next you need to draw the K map to get the logic expression. So you need to draw the K map. What are the inputs? D8, D4, D2, D1. 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So you need to draw the means you need to write the number of ones in the cells. Uh, so 0 is 1, 2 is 1, 4 is 1, 6 is 1, and 8 is 1. Remaining all are don't cares only. Remaining all are don't cares only. Okay. So first you need to see for any octet. Octet is possible or not. If you consider this as one, these corner grouping is allowed. This one and this one makes one octet. Okay. So if you see this one, which is common, so D2 bar, D1 bar, D2 bar, D1. So D2, D2, D1 bar. Sorry, D2, D1 bar. D2, D1 bar means D1 bar is common. So what is my expression? That is Y equal to D1 bar. This is my expression. From this you can draw the logic circuit. That means D1 is one input connected to the inverter. So here Y equal to D1 bar. Is it fine? Do you understood how I am realizing?
Sir, why we take that don't care as one, sir? It would be also zero, no, sir?
But suppose depending on the possibility, so in the K maps we already discussed. I think you are there or not. So K map. Suppose if you consider this as zero, you are getting what? Suppose this considering this as zero, this is one quad, two quads you are getting. Understood? Two chords means two prime implicants you are getting. Suppose if I am considering this as one, these two as one, I will consider this as zero only. Okay. I don't want
Okay,
one more prime implicant. So this one I am considering as one means I am getting one octet. No,
sir.
octet.
So,
Um,
we having that one in 10th block, sorry,
hmm.
6th block. That's why we are pairing that also
Yeah, yeah,
in that side also two
yeah.
ones. Okay.
0, 4 and 8 block one is there. 2, 6, 10 block, 10 also we need to consider as one.
Uh,
Okay.
if we didn't do that, it will be alone with one.
Yeah,
So
yeah,
it can't be paired with any
yeah.
other block.
Hmm.
So we want to pair that also that also. Okay.
Yeah, yeah. Means when you are doing the key map, you should be less number of variables. We need to
Okay.
group such a way
So
that
low number of laterals.
literals. Yeah, yeah. Is it fine?
Okay. Yes, sir. Yes.
What about others? Shall I move forward?
Yeah, sir, move forward.
Okay, yeah. So your task is same question, same question. Okay, same same question. You need to design uh, the minimal function that can detect divisible by 3, divisible by 3, okay, with 8421 bcd code. So what is my bcd code? D8, D4, D2 and D1. Understood? Previously we did with divisible by 2. Okay, same thing here. That means here if it is divisible by 3 means what? If it is 3, the output is 1, and 6 output is 1, 9 output is 1, remaining outputs are zeros only. For 0 output is 1, like that. Need to design. Will you design or shall I explain?
Yes, sir. Sir, can you say that how many inputs we take, sir? That
Same thing,
how could we
same.
consider that only this much inputs only we want to consider?
So BCD, the range is from 0 to 9 only. BCD range is what? BCD range is 0 to 9. Okay. So 0 to 9 means already in the question you have how many inputs? So 4 inputs they given. Okay. So that means if there are n inputs, how many possible combinations in the truth table you will get? 2 power n, no? So 4 inputs are there. 4 inputs means you need to take how many possible combinations? 2 power 4. That is 16.
16.
Understood? 16. Only one output is there. So one output, that means inputs are 4. Output is
Output is 1.
1 y. Okay. So your inputs you write like D8, D4, D2 and D1, and output is what? Y. So just you write 0 0 0 0 0
So
0.
then we only consider in BCD range only, sir, when we design
Yeah,
this.
BCD range is represented as 0 to 9 only. Suppose when we discuss a BCD adder, that there I will tell you. Suppose 1 2 is there.
Yes.
1 2 in BCD is there. We need to declare separately 0 0 0 1 and 0 0 1 0. Like this
Yes, sir.
separately we need to declare. Okay.
Okay, okay.
There is a concept of valid BCD and invalid BCD. When we discuss the BCD adder, that I will tell you the concept.
Okay, sir. Okay.
Okay. So this task you can do, no?
Yes, sir, we can.
Okay. Next you see. Next, suppose combinational circuit is given. In terms of gate, the combinational circuit is given. How to realize? So it is one circuit and OR gate, AND gate and OR gate. This is XOR gate. A, B, C and D. This is one more XOR gate, and this output is given to one more XNOR gate. So it's asking what is the y value? What is the value of y? So how to do this one? So just here, what is the output? Let us take the output is what? Output is this is AND gate.
AB.
AB, yeah, AND gate. So AND gate means this is AB. Okay, 1 second. This is AB. This is AB. Let us take AB as X. AB as X. Okay, AB as X. Okay, this is NAND gate. NAND gate. Okay, this is NAND gate. So NAND gate means here you will get a AB bar. So AB bar means what? X bar. Okay. So here you will get X plus X bar. In Boolean algebra we already seen, no? A plus A bar. What is A plus A bar?
1.
1, no? Yeah, 1. So this is 1. You are getting 1 over here. And here you are getting C over here. And so this is XOR gate, no? So this is XOR gate. So XOR gate C XOR 1 equal to, you know the expression for A XOR B, that is A bar B plus AB bar. So C bar and 1 plus C and 1 bar means 0. Okay, this is C bar plus 0. This is C bar. So this is C bar, and here D, and this is D bar. It is given to XOR gate. So D XOR D bar. A bar B. D bar D bar plus AB. D D bar. So This is d bar is d bar plus 0. So this is the d bar. So the output, one second, mm, d bar, a bar b plus ab bar. Okay. So here whole bar means this is d bar plus d means 1. Okay, this is 1 only. This one. D bar plus d is nothing but 1. Okay, the output is 1. Output is 1. And this is given to one XOR gate. So here the output is C bar XNOR 1. So A XNOR B equal to A bar B bar plus AB. So this you can write as D bar C bar whole bar and 1 bar C bar and 1. So this is C and 0 plus C bar and 1. So 0 plus C bar, 0 plus C bar equal to C bar. So Y equal to, you will get the output as C bar. You understood how I am doing?
Yes, sir. Sir, can you explain once again?
See here, this is the logic diagram. First, this one is okay. So this one is AB, no? AB means what? I am considering as X. So this is NAND gate, AB bar. AB bar means what? X bar, no? So this is OR gate. OR gate means X plus X bar equal to what? X plus X bar equal to what? 1, no?
One.
1. And one more input is coming to through this XOR gate, that is C. Okay. So A XOR B equal to what? A bar B plus AB bar, no? So C XOR 1. So just substitute C bar and 1 plus C and 1 bar. So this is C bar plus C and this is 0. Okay. So C bar plus 0, this is equal to C bar. Okay. So output equal to what? C bar you are getting. Okay. And next, coming to this one, mm, one second. So coming to this gate, this is nothing but D XOR D bar. Okay. So A XOR B, you know, A XOR B equal to A bar B plus AB bar. Okay. So D bar, D bar, D bar plus D, D bar whole bar. Okay. So this is the D bar is D bar, you can write. Again, D bar whole bar equal to what? D only. D and D you can write as D. Okay. So this is equal to what? You know that A plus A bar equal to what? 1, no? A plus A bar equal to 1. So here you will get 1. Okay. So what are the inputs you are getting? This is C bar and this is 1. C bar and 1. Okay. So here if you see, this is X NOR gate. X NOR gate. Okay. So X NOR gate, you know, A X NOR B equal to what? A bar B bar plus AB. Okay. So C bar X NOR 1 equal to C bar whole bar and this is 1 bar plus C bar and 1. So this is C bar whole bar is C, 1 bar is 0 plus C bar and 1. So this is 0 plus C bar, this is equal to what? C bar. So you are getting Y equal to C bar. Y equal to C bar. Is it fine? Do you understood?
Yes, sir.
Okay. Yeah. Next you see, you need to find out the redundant gate. You need to find out the redundant gate. Okay, how to find out the redundant gate? Suppose to find the redundant gate. To find the redundant gate, just so this gate is given. Redundant gate is nothing but like you need to find out the expressions. So if the variables are like repeating, so that becomes the redundant gate. Okay. So just with example, you can understand very well. So this is the one NAND gate, and this is one more NAND gate, and this output is given to one more NOR gate. NOR gate. So this is A, B bar, C, A bar, B bar, C, A, B, C bar. Okay. So how to find out the redundant gate means here what you will get this is A, B bar, C whole bar. Okay. So this you can write as what A bar plus B bar whole bar plus C bar. Okay. So this is equal to A bar plus B plus C bar. Okay. And next this one A bar, B bar, C whole bar. Apply Demargan's law. Just I am applying the Demargan's law. Okay. So A bar whole bar plus B bar whole bar plus C bar. So this is equal to A R B R C bar. Okay. And next A B C bar whole bar. So this is A bar plus B bar plus C bar whole bar. So this is A bar plus B bar plus C. Okay. So here I need to find out the common gates. Suppose A bar is there. A bar. A bar where it is repeating, here it is repeating. Okay. And A bar. B is there. B where it is repeating. B anywhere it is repeating. Anywhere it is repeating. B.
No, sir.
One second. B here it is repeating. B here it is repeating. B here it is repeating. Okay. Next C bar. C bar. C bar also it is repeating.
Repeating.
So that means this is the redundant gate. Okay. If you check here, A anywhere repeating, A
No,
anywhere
sir.
repeating. So B anywhere repeating, B is repeating. Okay. C bar also repeating. So A is not repeating. That's why this is not a redundant gate. This gate should be present. Okay. And here if you see, A bar is repeating. B bar also, B bar is not repeating. So B bar is not repeating. Means this is redundant gate, not a redundant gate. Did you understood how to find out the redundant gate?
So that redundant is only that it is repeating, sir, or non-repeating, sir.
When it is repeating, that becomes the redundant gate. This is the redundant gate. Redundant means what? When you eliminate this gate, the output equation will not affect. Like it's like a in K-map, you have essential and non-essential prime implicants. No? Non-essential, I told you how to find out the non-essential prime implicants. Like same non-essential prime implicants, you have a redundant gate. Did
So
you
here
understand?
we getting B and C bar.
Hmm. So if you consider the gate one, A bar is repeating. Where it is repeating, here it is repeating.
Yes,
B
sir.
where it is repeating, here it is repeating. Okay. C bar you see. C bar also here it is repeating. So that means this is the redundant gate.
So it will be more number of times will be repeated. Then we conclude that, sir.
All variables are repeating means that is the redundant gate. You need to check
So then we can consider that gate, sir.
that gate is a redundant gate.
Okay.
Understood?
Yes.
Okay.
Sir, final equation, what is?
Yeah, final equation is this is NOR gate, no? So NOR gate means this is AR, BR, C bar, or next A bar, or B bar, or C whole bar. Okay, so that means here AR, BR, C bar, whole bar, and A bar, or B bar, or C. Only you will get the equation from these two. Here the question is he is asking only the redundant gate. He is not asking the final equation. We need to identify the redundant gate.
Okay, sir.
Okay, yeah. Any doubts? Shall I move forward?
No,
Waiting for your response.
no, sir.
No, sir.
We can move.
Okay, okay, yeah. Find the redundant gate. Yeah, find the redundant gate. Okay, this is task 1, task 2, task 3. A, B bar, C, A, B, C, and A bar, B bar, C bar. A bar, B bar, C bar. Find the redundant gate. Why? 1, 2, 3, 4. You will do or shall I explain this?
It is task now, sir. We can try, sir.
It is task you try. Yeah, next session we'll start the half adder and full adder circuit. Okay?
Okay, sir. In combination circuits, sir.
Yeah, in combinational circuits we'll start the half adder and full adder circuit.
Yeah, sir, can you display the task one, sir?